Sorry guys for messing up the video. This is the same video that was already on my channel, but I didn't realize there were some footages that were duplicated. There was some stuff that I was supposed to delete it, but I didn't. Anyhow, but I think it's a good video. This is a Chevy truck where we had a misfire, a random misfire, and the PCM could not detect the what cylinder is misfiring, and misfire counter was not helpful at all. So I think it's kind of good to see this video, to see my approach, what I was doing and how I was able to, what equipment I used to find the problem. It's nothing really big deal, but it is interesting, I believe. Now, when I looked my history in misfire, I noticed that the cylinder number 4 had most of the misfires. So this was a AFM engine, active fuel management engine, where I was a little concerned that the maybe AFM system wasn't working right, because number 4 cylinder is in that system, 4 and 6 and 1 and 7. And to make story short, I have checked all that is fine. I was able to use my bidirectional control and activate each of the cylinders, and they're all working fine. The reason I was concerned because of that, when I looked my freeze frame data, the car was driven at 50 miles an hour on a cruising speed, and that's the time the computer actually activates the AFM system. And but the issue was completely different. Anyhow, I'm going to clean all that stuff out, and I think it's going to be a lot shorter and more interesting. Again, I apologize, but for you guys who already watched this video, there's nothing new on it, okay? Well, thank you so much, and appreciate you guys. Thank you. Bye-bye. 2012 Chevy Silverado, 5.3 liter engine. Complaint was that the car kind of truck lost power and wouldn't go over 40 miles an hour. And the owner told me it sounds like it felt like the went into the limpo mode. So my first thought was a throttle body code or something like that. And so anyhow, we're dealing with a random misfire, P0300. Their check engine light is not on at this point. Looking at the misfire data, I see nothing. 2, 4, 6, it's all good, and 8. 1, 3, 5, and 7. No, it's one kind of like a 2 on number 7, but nothing really that indicates, you know, right now it's not misfiring. And now in the history we have a misfire number 4, and the other ones are okay. It's like number 2 as well, but mostly on number 4. Now when I look at the freeze frame, so we got an engine misfire detected, and so now on the freeze frame we have seen that it's actually under load, probably like a cruising speed. It's a fully warmed up in a closed loop, and engine load was at 37%. So kind of cruising speed. Engine RPM was 1400, and speed was like 51 right there. And then fuel trim looked okay. There's a little bit of short and long on number 1, looked perfect. 0 and -4. Now it's a little in negative on bank 2, -10 on short and -2 on long term. So not too bad, but you know. So anyhow, this was under load, so to speak. You know, it's not like a full throttle, but it's cruising speed. And so I'm just going to take it for a test drive and look at the misfire data and see if I see anything or not. Right now I really don't feel any misfire at all, so I'm just going to customize it, and I'm going to take it for a test drive and see what happens. Okay, so 2, 4, 6, I'm missing 1. Okay. Pick for test drive. I'm at the cruising speed. Truck is fine. There were no misfires at all detected at the idle. The number 7 was showing couple, but nothing significant. And this truck is a little slow because it has these big old tires, I guess, big off-road tires, and it kind of drags a little bit. But you know, engine-wise, I don't feel any misfire at all at this point. I'm trying to recreate the same conditions at the I don't know, 50 miles an hour, slight acceleration, but nothing yet. Okay, I just did a wide open throttle. Everything looks okay. As soon as I accelerated, my upstream sensor went rich. This is when they're shifting actually gears here, so that looks okay. This whole time was actually rich, so I'm happy with that. So that looks. I'm still going after ignition. This time I actually decided to use a different ignition tool. Basically, this is a snap-on SIA secondary ignition adapter. I think it's SIA 300 or something like that, and 2000. SIA 2000 stands for secondary ignition adapter. Now, the reason I choose this tool this time, not my my long probe that I can actually put across all of the coils. These coils are actually designed a little bit different. Generally, I would put my probe right on top of it, but there's not much room. And since this is a coil mirror plug, we have another option that we can actually get ignition straight from our spark plug wires. Having this tool, I have a green and yellow, basically two sides. They all have like a 4 leads, so you can go up to 8 cylinders. And right here you can see I have actually 2 channels, green and yellow. Now I did mark to myself as like a positive and negative. So there's a green and there's a yellow side. And so I don't mix them up. You really cannot mix them up because they are divided anyway. So what I basically have 4 cables are hooked up to a 4 spark plug wires. You got this inductive pickup clamp, and it's clamped to each of the wires, and the same on the other side as well. Next, I have a now the nice thing about this setup is that I'm already protected. This setup already has, I don't know, is it a diode or is it a capacitor in case that one of the wires are open. So you have this ground wire that you have to ground to the engine block, and this allows me to basically use my scope leads. I can hook up my leads straight to this machine here, to this tool. And as a sync, I still have my snap-on single probe. I put it on the coil number 1. So we got 1, 3, 5, and 7, and 2, 4, 6, and 8. And so the setup is, so you can see what I've done in the engine bay. And so here you got one. This cable comes from the tool, and now you have these 2 leads. You have these 2 leads that come out, and basically I have a 2. You got yellow. I'm sorry. You got a green and yellow lead, and now you have a ground. And as I said before, so the green is going to be the bank 1, and yellow is going to be bank 2. However, it's going to be different on my scope. On my scope, the bank 1 is going to be in the blue channel, and bank 2 is going to be on the red channel. I know it's a little confusing, but that's the way it's going to be. In order to work on this, you got to now have three channels, and this is what I have here. And as I can, this is the channel 1. This is the blue channel. This is going to be the bank 1. And let's just kind of zoom this in a little bit. The blue will be still in a number. Now the firing order 1, 8, 7, 2, 6, 5, 4, and 3. So this odd number is going to be on this here. So now the green channel here, that's my sync. This is number number 1, that I have my single pickup, my single pickup on it. And so it's going to be all of the 8 events going to be between these two ignition waveforms. And as I said, so this is bank 1, and we have 1, 7, 5, and number 3 cylinder, and then this bank 2, this second channel, we have 8, 2, 6, and 4. Now I can simply just line them up like this and have kind of one channel basically, but I can do this as well. It's just an option, whatever I want to do. I had to invert my waveforms because they're upside down, and so let's go ahead and run the scope and see the waveforms. And as you can see that I actually have my sync on the channel number 3, and now we should have 1, 2, 3, 4, 5, 6, 7, 8 waveforms. And right away I can see a problem on this cylinder here. You can see how this is jumping up and down. Let's see that right there. So I have to say that this machine, actually this tool makes much better waveform than using the pedal, or so if you have an option to get the ignition waveform straight from spark plug wire, you're going to have a better waveform. And that being said, you can see on the right here we have a dwell time. Let's zoom on this one here. We have a dwell time, we have a burn time, we have a power kV, and I also have a spark kV. And this is part of the waveform that we usually don't see it if we're getting a waveform straight from the coil. And this is actually a very nice part of the waveform. This is the a power kV. This is the power needed to actually start the spark. And this here, this line here presents a spark kV, which actually is a power needed to maintain your spark on your burn, basically spark on a spark plug. And that should never change at the idle, because the resistance in the cylinder is always the same, meaning a compression, a fuel mixture, and also the resistance inside the wiring. There will be a plug, coil, or spark plug itself. And as we can see here on this cylinder, how high this power kV went up. And this is a classic example of outside of the combustion chamber problem. And we pretty much need plugs and wires. We need a tune-up on this engine. And so now we can figure out, as you can see on this cylinder and this cylinder, so there's a multiple misfires, and so this will be bank 2, and that will be 8, 2, 6, and 4. So this is cylinder 4, one that was detected by the computer as well. And the on a bank 1, this will be cylinder number 3. So 4 and 3 are right now having a misfire. And but I've seen some more. Let's go back. Now we can see here, this is actually, this is a big one. You couldn't even catch it all the way. And this one is actually number 2. Interesting. So, and again we are having a number 3 here. So number 3 looks like it's more consistent. Let's go back. See here, number 3, and then here number 3 misfires. So we got two misfires on number 4. Now this one is okay. Now I don't see any misfires. So this is intermittent problem, definitely intermittent. But again, look at number 4 again. Number 4, and now we have a number 3. I'm sorry. This is number 3, and then a number 5 a little bit, and number 2. So these are odd numbers here. This is not. So this is a number 7, 5, and 3. I'm sorry, I was saying 4. I guess I don't remember. But anyway, have a constant misfire on this number, on number 3 here. So let's go back to say number 3 again here, and number 3 again here. So every time you see these elevated power kV, that's the misfire outside of the combustion chamber, and we can do a tune-up. There's the number 3 again. But how nice it is to have a ignition waveform that we can actually, this is number 2, because I really could not feel the misfire that pronounced, because this engine pretty much goes from one cylinder, and 2 again, look at that. So anyhow, that is number 3 back here. So that's it. I mean, this is nothing really. You can see the number. Seems like number 3 has the most. The computer was actually flagging most of it on number 4, so, which is actually this one here. But I have not seen many misfires on that cylinder at all. And this is number 1 here. And then number 6. But anyhow, I mean, I don't want to repeat myself over and over again, but you can see this misfire just goes from one cylinder to another, and it's definitely multiple cylinder misfire. Again, number 3, it's the one that misfires the most, and we can go ahead and get new plugs and wires. And then got the plugs removed from bank 1, and put them 1, 3, 5, and 7. And I mean, these plugs have seen better days for sure, but look at the number 7. I mean, this electrode is burned completely. It's broken. So it's kind of weird that you can see there's more carbon buildup than well, not really. Definitely, you know, a damaged plug. So this is number 1, and then number 7 is here, and 7 is here. I mean, it's actually firing pretty good. It's really weird the way that, maybe, I don't know, it's just crazy. And there's a 7 again, unless I have a incorrect the firing order, but I mean, 7 was actually pretty decent compared to what it actually looks like. 2, 4, 6, 8, they all look pretty much the same, not much. They're all old, and the gap is excessive on it, but you know, nothing that's not as bad as number 7. I actually talked to him a couple hours ago, and he told me that he did have 307 code prior to this last problem that he had, and that was like maybe a couple of weeks ago, and then he said the code went away, check engine light went away, and he didn't have any problems until this weekend, like 2 days ago. And then he, you know, called me and asked me if I can take a look at it. So definitely plugs are a problem. Let's start it up. Kind of froze for some reason. See where my okay. All right. This is actually a good example of what happens when you don't have your trigger set up right. I had it set up in the same spot, but you can see that my waveform disappeared. So I turned my trigger off, and my waveform came back. So what happened here is that, you know, it would not, now, yeah, I did not put my my coil, my pickup probe in the same spot, so my waveform is smaller, and the trigger wouldn't capture it, so there was nothing on the screen. I'm going to change this scale here a little bit now, so that I can increase my voltage, or maybe I can just move my probe. some reason I'm not getting anything now. There you go. It's better. I'll stop this for a second. I want to look at this waveform. Is it upside down or... Oh, it's not. Okay. How much nicer this waveform is versus one of the Pro ones that you're actually getting from the coil itself versus from the spark plug wire. Yes, now get my trigger here. See that? Yeah, there you go. My waveform did not meet the threshold, and then my trigger wouldn't work, and all of a sudden none of the channels will be displayed. Pretty good example of what you need to do. Just you know, get rid of your trigger, get your waveform on the screen, and then play with the trigger again. And let's just stop right now and see my waveform and see if we have any of those misfires that we had before. So far everything looks okay. Let's go to number 21. We had a pretty frequent misfire. I think it's number 3. I don't remember which one was it, but you know, it was pretty much consistent on one cylinder. And now we can see that all that misfire is gone. How nice is that? Nice and clean waveform on each and every cylinder. This is 20. Perfect. Okay, let me go change my... There we go. My scaling was different between two channels, but that's not a big deal. But we do see that our misfire is gone. We had a multiple cylinder misfires, and 100% proved by ignition waveforms. Right now, all that is taken care of. We could see the plugs are in pretty bad shape, and pretty nice. I've already moved to the next one. I actually have another car from the same owner. And so what I want to emphasize in this video is that we cannot always rely on the scan tool. On my recent video, I had a comment where somebody made a comment where why bother doing all the testing if you can simply take a scan tool and look for the misfire and get the idea of what cylinder is misfiring. Of course, the scan tool is not going to tell us what is it. Is it ignition, compression, fuel, whatever? But that works like 90% of the time. I had cases where actually power control module would misidentify cylinder, and then it's going to throw you off the loop. But that's a good way of doing it. Sure, you're going to take a scan tool, and nowadays the cars the control modules are better and better to be able to identify the cylinder, but that's not always the case. In this case, I really could not even feel the misfire. We took the car for the test drive. We look at the live data on the misfire. Nothing happened, or not. We could see a couple on cylinder number 7, but nothing really excessive. That was at the idle. You would think for the plug, that such a bad plug that was on the number 7, that you would actually have a misfire under load, but this truck ran fine. And sometimes I don't understand how this even works. How that plug could work today and that wouldn't work tomorrow and then work again for next week or so. I mean, I don't know, it's crazy to me. We could see that all the plugs are worn out, the gap was excessive on it. So, but this is a good example where we need to have a diagnostic tools that could gather more data and to give us a funnel what to do next. Now, during the test drive, I also done a wide open throttle where we could see that an oxygen sensor working fine. That during the acceleration, our oxygen sensor went rich. That gives you actually idea that gives you information, you gather information by doing that. Your fuel pump is okay, the fuel filter is not clogged up, the mass airflow sensor is okay, your fuel injectors are spraying, delivering a sufficient amount of fuel to each bank, because oxygen sensor bank 1 and bank 2 enrich. So that's a lot of data, that's a lot of information we gather from that one test. And what I did, well, I said, well, that's not the problem. Let's see if we can do something else. And doing a ignition waveform literally show what the problem was. Now, in this case, I choose to use my SIA 2000. It was easier to me to gain access to my spark plug wires, because the coil is a little bit different, and putting my probe would not really fit right. I could probably get the waveform, but it was just easier for me to use my SIA 2000. Now, as I said, I mostly use picoscope for ignition analysis. You can use any other scopes you wish. I'm not sure on a snap-on scopes. I didn't really play with them much when it comes to ignition. This SIA 2000, I think you can use a ignition scope mode, and then you connect the tool, and you have to have the sync, and you should be able to get the all of the ignition waveforms that way. I'm sorry, as well. Now, if I would not choose this route, you know, if I would not look at the ignition waveform, what do? Tell the owner, okay, let's just wait until it gets worse, and that's pretty much you can do anyway. Now, we can argue, you know, how long does it take to set up the equipment? It takes time, of course. More you do, if you faster you get with like anything else. And now, if you don't want to spend time to educate yourself and train yourself, don't even bother buying all these fancy tools, because they will not work for you. If they're hanging on the walls and sitting in the drawer, they're just you know, a lot of money wasted for nothing. But they are useful tools. You just have to spend time. So I was actually fortunate to be able to afford buying all these tools, and I've been buying them off of eBay, used. None of these tools are ever new. None of the scan tools, my picoscope, everything is used. And I would buy them off of eBay, and you know, collected my tools over the years, and each tool has its place. You just have to know at the right time how to use it and collect your data. Now, looking at the now, how powerful is secondary ignition waveform, and that's something that I always use. I mean, I'm not good at it, but by now I can actually decipher different segments of my ignition waveform, that I can actually figure out what the problem is by looking at the waveform. You know, okay, if you see all 8 ignition events, right away you know that power control module is able to energize or send a signal in this case, because the driver is actually inside the coil itself. So the computer is controlling, signal to each of the coils. That tells you the cam and crankshaft sensor is okay, because without a signal of cam and crank, you will not be able to, the computer will not be able to correctly control the coils. So that's another thing we can look through on the ignition waveform. So the cam and crank is okay, the signals are okay, the computer is able to control it. Then looking at the power KV, we can tell that actually on this system, when you're getting actually a ignition waveform from the wire itself, the spark plug wire itself, we can actually rely on that data that tells you what's the KV, actually how much KV that the coil can deliver. Now, usually around it's like 15 to, I don't know, 17 kV at the idle, but what it tells you that tells you that actually coil itself is okay, it's able to produce enough voltage. Also tells you that power and ground is good on each coil, so you don't have to check that either. So there's so much we can learn from the ignition waveform, not just looking at the problem, just all this data we can actually get from those waveforms. Now, when we get into the waveform itself, we're looking at the power KV, we're looking at the spark KV. A couple of times I misspoke. when I said power kV, I meant spark kV. And luckily, on this case, by using SIA 2000, I was able to actually see the dwell time. Dwell time is the time how long computer actually energized the coil. It will be the same as your current ramp. Then I could see the power kV, I could see the spark kV, and I could see the burn time. And then you can see the power kV kept jumping. That power kV actually is a voltage needed to maintain your spark, and at the idle they should be consistent. It shouldn't change. There's no reason for that to change so much. And if you see that, then it's an indication that you have an outside of combustion chamber problem, meaning the plugs, spark plugs, wires, or coil. And we could see that it was very nice waveforms. You could see it's jumping from one cylinder to another, and this way I could I called the owner and told him without even touching the spark plugs, we need to do a tune-up on this car, on this engine. It's easy as that. Now 100% sure that I need to change spark plugs and wires, and when we did, you can see what condition of the plugs were. And now again, we can argue, you know, how long does it take to set up, and what would you do in this case? You know, then you need to take the spark plugs out and inspect each plug. You see the condition of the plug, and then, you know, do your tune-up. Or again, this is not that big of a deal. You know, this case study is not that big of a deal, but it is nice to see, you know, even though how powerful that ignition waveform is, that you don't feel the misfire on the engine, yet you can actually see it on the ignition waveform. That is awesome. That really is. And it's no guessing, you know, okay, this is what I've seen, 100% sure I need to do what I need to do. And also to confirm your repair after you replace plugs and wires, let's do it again. Let's put our tools back on, let's connect our tools, let's connect the lab scope and look at the waveforms and see, did it go away? And it sure did. Very nice. And that's about it. So I'm not sure how long this video is gonna take, but I want to thank everybody for supporting my channel, for watching my videos. I apologize for my late contents on my channel. Most of that I'm dealing with you know, ignition problems, and maybe like I had a couple with bad fuel pump. But you know, it's just the way it is. You know, whatever comes in, you work on it, and if it's something interesting, I will film it. I'm gonna have something better, I guess, next time. So anyhow, appreciate you guys watching, and see you next time. Bye bye.